All right, cool. Thanks for joining. About to get started on my next algorithm. So next one should be find minimum in rotated sorted array. Cool. So let's dive right in. Suppose an array of length n is sorted in ascending order. Sorted in ascending order. I'll just copy that and paste it. Okay. For example, oh, these are not sorted. All right. Sorted in ascending order is rotated between 1 and n times. 1, 2, 3, 4. Okay, got it. 0, 1, 2, 4. So it kind of was ascending and now it's sorted. Given the sorted rotated array nums of unique elements, return the minimum element in this array, Okay. Right, so the easy thing to do would be to just loop through and find the minimum. But they want O log n, so we can do better than linear. Let's see, maybe a binary search. I'm going to do kind of a comment, maybe binary search. It's the only thing that really comes to mind, to be honest, that's going to be O of n time. Okay, so I'm thinking about doing a binary tree search. So or a binary search. So start in the middle and then check left and right. And I should expect that it's ascending. And if I find a lower number, then that is where the rotation started. Start in middle, check left and right, keep splitting, following binary search. So let's say I do find, when I do find an inflection point, so the inflection point will be like right here. I might not immediately find it that way. I might imagine this was really big and there were a bunch of other numbers. I might just find that 0 is less than 7, but they're not adjacent. There could be numbers in between them. What is is 0 the minimum? Okay. All integers of nums are unique. Okay, no, they could go as low as negative 5,000. Okay, so 0 is not the minimum. Oh, thank you for the likes. Thanks for joining. You're going to get a better view of the screen if you watch on YouTube or Twitch. So the handle is John Vandeveer. Same as my TikTok handle. So thanks for being here. But if you want to see the full screen, check out YouTube or Twitch. Okay, so I'm going to detect the 7-0 situation, although they might not be adjacent. But what I know is that 7 should have gone up. So the fact that it went down, that's what I'm calling inflection. So yeah, if left is ever greater than right, if left is ever greater than right, then I want to zoom into that area basically. And I guess the hacky way to do it would just be to loop through that. Coding. Yeah, we're coding. I'm still kind of like thinking through the prompt at this point. I can show you the code. I've just written comments up till now. So kind of at the pseudocode stage. Thanks for the follow. I appreciate that. So hacky zoom in is loop within the block. Better thing to do is keep doing a binary search approach. Okay, so let's try it. So we're gonna try binary search basically. So we want to get left and right, compare, repeat, and then eventually return. We want to find the minimum value. So yeah, let all time min equal negative infinity. Okay, and then we'll eventually return all time min. One thing I can do, I can actually set all time min to, I can guess that it's the first index. That will actually get you some minor performance improvements because it could be low, or it could also help you detect. So this will actually be the initial left. Yeah, let left equal. Not like num0, so that will be our initial left, and then right can be the midpoint. Set right to midpoint. If right greater than left, if the right is greater than the left, do we still know what's going on? Hold on, let's go back over here. Let's look at a test case. So I'm going to take 4, and then right could be the midpoint. If I find 0, then I know that the inflection point is between them. That's correct. But if I find 5, like what if I find 10? Does that mean that the inflection point was not between them? So I think I might want a third pointer. Four, 5, 6, 7, and what if it's 10? So it could be like 4, 5, 0, 10. No, because they're sorted. So it'll never go 4, 5, 0, 10. That'll never happen. That'll never happen. Okay, so this is correct. Set right to midpoint. If right is greater than left, then it doesn't contain in left half. Inflection, it doesn't contain inflection in left half. Okay? You got the all-time min, set the left, set the right, and then so let right equals nums nums.length -1. So that'll be the far right element. Yeah. So I think I want to call this, I think I want like a middle pointer, no? Because of course left is going to be less than right. Is that true? Left is going to be less than right. Might not be true if right is the actual inflection point. Edge case is whether nums.length is odd or even. So I'm going to say to do solve for. So this is pretty naive, this right here. I actually technically need to check whether nums.length is odd or even, but we're just going to get something that's kind of working and then improve on it. So the all-time min, I'm not actually tracking anything with that, although I'll eventually return it. I'm going to have a left, right, and middle. I'm pretty happy with that I want 3 pointers. Cool. So get left and right, compare, repeat. I guess we can do a while loop here. Let's see, can I do a while loop or do I need my indices? So I could track for loop versus while loop. I like this while because it is a pinching pattern. Currently like pinching pattern using indices plus while. So I'll have a left index and a right index, and whenever they pinch down, that's how I know to exit the loop. So instead of left, here's the left value. These are all values, right? I'm going to do indices instead. Cool. Okay. So while left is less than right, while left is less than right. I think that's a good condition. So we'll stick with that, and then I might come back and revise it. But if left and right are ever equal, then that has to be a settling point. Does that make sense? So these are going to be indices. So here I'll do const left value equals nums left. And I could call this like left idx. It's probably a touch more clear. So let's do that. Right idx. This is middle idx, the index. I'm actually not super sure I even need middle. But let's keep flowing. At the end of this loop, I'll do the all-time min equals math.min of current min and left value and right value. Const right value is nums right. Nice to see a coder on live. Thank you so much, Junkyard Guy. Appreciate it. If you're on TikTok, thanks for watching, but you'll probably get a better view of the screen if you hop over to YouTube or Twitch. The handle is the same, John Vanderveer. Okay, so we have the left and right value, and then we want to compare them. So if left value is greater than right value, must contain inflection point. That is the non-rotated index of 1, 0 index. Okay, so let me make sure that's correct. I think that's correct. So normally the left value should be less than the right. 1, 2, 3, 4, 5, right? So the left value would only be larger than the right if the inflection point is contained, okay? Yeah. You changed variable names, line 20. Yep, thank you, appreciate it. Good catch. Okay, so must contain the inflection point or the non-rotated 0 index value. And then it's like, so what? Otherwise, See, this is why I do need the middle index. The entire array must have an inflection somewhere. Does it? Okay, no, if it doesn't, if the entire array, like let's say it's 1, 2, 3, 4, 5, the entire array does not contain an inflection point, then the minimum would be left value, I think. To do double check, this is valid. So in that case, I would just return left value. Feels not quite right. I think. So left is 0 and right is the very end. That would be the entire array. So that's okay. Yeah. Introducing a middle pointer doesn't hurt anything, but it's like, is it needed? So in the case that the entire array is literally sorted, it's not needed. What about if the subarray is sorted? So let's consider like one of their examples, like 3, 4, 5, 1, 2. Test. 3, 4, 5, 1, 2. By the way, I should think about the edge case if it's like 0 or 1 length. So it can be 1 length. So if it's 1 length, it's never going to be 0 length according to the prompt. So if it's 1 length, I can just return 1. To do maybe special case if length is exactly 2. For now, I'm just going to handle if the length is 1. If nums.length is 1, return nums 0. And you know what? This would handle that anyway. So that starts at 0, and then here is the length minus 1. So this would also be 0. So while it's less than, so it would skip the block and it would just return that. So I don't need the guard clause anyway. So I don't think I need to give any special handling to that. Okay, cool. So 1, 2, 3, 4, 5. R.I.P. Betty. Okay, so we already talked about this. This is good. Just if nums is sorted in ascending order, isn't min always just nums 0? That would be the case. Who is that box dude? That would be the case, that box dude, but that is not the prompt. The prompt is that nums is, okay, yeah, sorted in ascending order, but rotated 0 to n times. So it's a sorted array. Yeah, it was an incomplete comment. You're right. It's sorted in ascending order, but it is then rotated between 0 and n times. So a valid test case is 1, 2, 3, 4, 5, and you're right. In that case, it would just be the 0 index. But we also have 3, 4, 5, 1, 2. And so the interesting part about this problem is detecting that inflection point as quickly as possible. Yeah, that would be super easy, wouldn't it? Okay. Let me recenter myself. TikTok is finally giving me coding lives. Let's go. Smash like if you like it. You'll be able to see the screen better if you go over to YouTube or Twitch. It's the same handle, John Vanderveer. Okay, cool. So in this case, left is greater than right, so must contain an inflection point. We're right about that. But then it's like, so what? How do I narrow it down? And that's the reason that I need this middle index. So let's say I pick a middle index of 5. Now I have a subarray, 3, 4, 5, and left value is not greater. So then in that case, can I just return the left value? Yes, I can. Yes, I can. Okay, so I tentatively believe that this is valid. Tentatively believe it. Okay, cool. So we know that it must contain the inflection point. Time to pick middle IDX. and narrow the window. So the question is, do I actually need a middle IDX, or can I just reset right? Can I just reset right? So let's say I do 5. Yeah, no, that's good. So I cannot return 3 because I'm looking for 1. So I pick 5. I've ruled out this space. Although it's possible that, so we'll set 3 as a candidate, but then I need to check this space. 3, 4, 5, 5, 1, 2. Yeah, so I think I want to do a recursive approach. To do recursively split array. This is like what a binary search is. I guess I'm just waking up or something. Recursively split array in half and carry the minimum up from that search. So I could do like DFS or BFS, maintain minimum somewhere. Okay, so while left is less than right. I want to like check left half. Let me comment this for a moment. What do they mean by rotated 0 to n? So you see 3, 4, 5, 1, 2 is rotated 2 places. It is the array 1, 2, 3, 4, 5, but then it is rotated 2. It's rotated by 2. And it could be rotated by 1, it could be rotated by 0, it could be rotated by 3. It could potentially be rotated up to 5 times. At that point, there'd be no point because like basically it's like a mod operation. It's a modular operation. So rotating it like 5 times is equivalent to rotating it 0 times, 6, and 1, so forth. So theoretically, they could rotate it like a billion times, but you could still describe it as between 0 and n. Okay. Define left and right subarray and check them. Min from subarray is a candidate for all time min. Okay. So const min left equals get min. I'm going to call it get min. Get min from array. And then const min right equals get min. Yeah, this is working. And really, I could just do equals get min from array of nums. Okay, so let me go define get min from array. Then it's going to be a little helper function up top. Const get min from array equals array. Return cur min. So left array. Let's get the so left index, right index, middle index. So left index, right index, middle index. So I'm going to literally average them, and then I'll do math dot floor to pick the lower one, and then to do does floor versus ceil matter. So like, does how we round that number matter? I think the answer is that we want the floor. So if there's one element, we want to take the 0 index, which would be 0 plus 1 divided by 2, taking the floor. If there are 3, then the last is 2 index. So due to this like -1 nature of JavaScript arrays, the off by 1 indexing, that's the reason that my intuition says that we should go for floor. So I'm going to go with that, but we can test it later. I will leave the to-do comment. I will leave it there because if we get to a step where we're debugging and we're like, what's going on? This could potentially help us. So I'll leave it there. So we have left, right, and middle. And what we want to do is const left subarray. By the way, these can all be const. I don't need to let. Const. They're not going to be changing. Const. And then const right subarray equals. That's going to be, I don't like using the term array here. I'll use cur array. I just am paranoid because array with a capital A is a reserved keyword, even though with a lowercase a it's not. Okay, so cur array dot, what is it, split? This is actually, the split thing is easier in Python, I think, because I always get split and splice mixed up. Oh, split is if you want to like split on a delimiter. So I think it's splice. And so we go from like left index to middle index, but I think that's wrong. I think that we need to do the count here. I think we need middle index minus left index. So I'll just say to do like verify syntax. Okay. So we go from the left index to the middle index minus the left index, which will just produce the count of elements that we want to proceed. Now, let's say if I go from 1 to 2, then I get a difference of 1. So that math checks out. I don't need to modify that. And then from here we will go starting with the middle index and increasing, right, IDX minus, okay, middle index, right, IDX minus middle index. So we got left array, right subarray. So then we'll return math.min per array. So that's the left subarray. Left min is get min from array. Left subarray. Right min is get min from array. Right subarray. And then we return math.min, left min, right min. Okay, so you can see the recursive pattern here, but I need a termination condition. Because this thing looks like an infinite loop. I don't actually have a termination condition for the loop to stop. So my intuition says like if oh yeah, if any of them are linked, or if any of these arrays, if any of these arrays are like length 1, then I can return the value. So that will terminate. That will always terminate. I think it's better if it's length 2. Yeah, so I think possible termination condition, possible recurse termination condition if length is less than 3, right? So if it's, or like actually if, yeah, if the length is less than 3. Um, okay. Terminate recursion, terminate recursion if length is less than 3. So left min is not always just get min from subarray. What we want to do is we want to see how big is that. So if else. So if dot length is less than 3. Okay, then if yeah, we can say let left min equal left subarray 0. So it's not a constant, right? We're going to use a let because it will be reassigned. Then we'll basically do the same thing for the right-hand side. What are other test cases? I'll show those on the screen. Those are some others while I finish out this thought. So those are some test cases. And you can make up your own too. You can make up your own test cases too. Okay. So here's the thought: is terminate recursion if length is less than 3, which is if it's 1 or 2. So if it's 1, you return the 1, and if it's 2, you return math.min between those. You might be like, hey, why don't we do math.min like on the whole array? Isn't that the problem? And the answer is because that would be O of n time. Here it is O of, it's constant time. It's either going to take, it's either O of 1 or O of 2, which is asymptotically O of 1. So you'll never get an O of n out of this. You just get constant. So basically get min from array is a constant time complexity function. Now, if you invoke a constant time complexity function in times, you end up with O of n, don't you? But because we're doing a binary search, we're going to invoke this constant function O log of n times. It's base 2 log. That's the time complexity of a binary search. So that find min will end up being O log of n. Okay, so what are you coding? We are coding get this Leetcode number 153, find minimum in rotated sorted array. Thanks for the likes. We're almost at 400. That's pretty cool. Happy New Year's Eve, by the way. Okay, so I kind of just want to hit the button and see it run. So we got this helper function, all time min. Right? Like, why not just return this? I don't think I actually need any of this other stuff. Let's see what it does. Cannot access, oops, sorry. Cannot access left index before initialization. Left index. Oh, okay. And that should be called cur array, not nums. Yep. Cool. Okay, so output is 2, expected 1. Totally agree. You should expect 1 there. I'm going to start blind 75 tomorrow, January 1st. Awesome. Here, let me follow you. All right, I requested to follow you in case you're streaming it. Okay, so what's going on? So come here, we get the 0 index of 3, we get the right index, which should take a value of 2. So we got 3 and 2. No, those are the indices. So 0 and 1, 2, 3, 4, 5 minus 1, so 4. 0 and 4, so then the middle index will be 2. 0, 1, 2, right? That is what I expect. So 5 is the correct middle index. And so, the splicing could be wrong. So let's do this. Log those. Yeah, so you see the splicing is wrong. How are you tackling blind? Do you have a weekly schedule? I'm just cramming it, dude. I'm not doing this the right way. You want to do this the right way? The blind 75 actually tells you how to do it. Here. So this is like the actual blind 75 list. And you can see this top comment right here. There's a 5-week schedule. That one. But what I'm doing, I have an interview at Google on the 4th. So I'm just like doing everything I can by, let's say, like noonish Sunday, and then I'm gonna rest for like a day. I don't want to be cramming to the last minute, having enough anxiety already. Cool. So we detected that the splicing is wrong. So 3, 4, it should be 3, 4, 5. So I'm going to do just +1 and see if I get my expected thingies. So now I got 3, 4, 5 on the left subarray, and I got what? I got nothing on the right subarray. I'm not expecting that either. Let me see. Can I just do left index to middle index? Right, okay. It's doing, it should be slice, not splice. So there's 3, 4, 5. Easter egg means God has plundered every nation. What? Are you okay? Three, 4, 5, 3, 4, 5, 1, 2. So 3, 4, 5. Three, 4, 5, 5, 1, 2. I don't like that either. 3, 4, 5, 1, 2. Okay, that works for me. So there we actually had clean slice, right? And what do you know? It was accepted. So this possibly was the only thing wrong. Let's see. And that worked. Okay, so the only thing wrong was that I was fucking slicing it wrong. That's pretty embarrassing because that's like, it's like basic syntax. Prefers. So we prefer floor over seal because of off by 1 indexing. And yeah, this is just one of those memorization things that got to remember how slice works. Thanks for the follow. Okay, so we made it through 1 minimum in rotated sorted subarray. Now we want to do search in rotated sorted array. Okay, it's basically what we just did, right? So I guess practice makes perfect. Let's read the prompt. There is an integer array nums sorted in ascending order with distinct values. Great. Prior to being passed to your function, nums is possibly rotated, unknown pivot index, right? This is the same setup, basically. Given the array after rotation, right, okay, makes sense. Return the index of target if it is in nums, or -1 if it is not in nums. Okay, great. So this is like super similar to the last problem. I actually love that. Drill it into my brain. So O of n, like naive, is O of n loop through nums. Faster would be binary search. I'll prefer recursive implementation. Okay, so that would be O of log n. So that's O of log n, and space, or yeah, so that would be the time complexity is O log n, and the space complexity, at any given time, what is the limiting case of stacks deep I could go? The limiting case of stacks deep I could go, is it also log of n? I'm really not sure. I'm going to call it O of n because I'm going to hold nums in memory. Ooh, is that a good reason? I don't know if that's a good reason to call it O of n. I would need another array of length nums. Do I have another array of length nums? I don't think so. Yeah, I do. Yeah, I do. So space is O of n because I'm going to have the left subarray and the right subarray, which sums up to the whole. So yeah. So the space is O of n because I have left subarray and right subarray. Okay, so we're going to just return get, let's see, get target. From subarray. Get target from array. Nums target. Okay. So I'll define this helper up here, get target from array. When return index or -1. And how we can check this, we just initialize the target index to -1. We just initialize it there. Cool. Bro, that's log in space if you do it recursively for BS. Okay, thanks. Hey, so what do you think about this? I'm going to take the numbers and I'm going to have a left subarray and a right subarray. So are you sure? Okay, let's see. Binary search space complexity. They're saying it's O of 1. Okay, so it's O of 1 if you do it in place, but I'm not doing it in place. Space complexity will be O log n. Okay, so why is this? We need 2 variable to keep track of the range of elements that are being checked. Oh, yeah, but I'm not using that. So they're using pointers, basically. I was actually using subarrays, like actual arrays. Do you know what I mean? Yeah, so it kind of sounds like we're both right. My implementation is O of n, but there is a possible implementation possible to do space O log n or even O of 1 if I search nums in place, only tracking pointers. So that's a good call out. We'll see if I can do that optimization at the end of this. For now, I'm gonna do the arrays just because it's easier in my brain. Okay, so here is left array. So const left array. We want the indices first. So const left idx equals 0. Const right idx equals nums dot length -1. We'll also need a like an offset. Okay. So left index is 0, right index is the length minus 1, and then the middle index is left index plus right index divided by 2. And round that all down. Okay. So we got the indices. Let's actually make the array. And then this is like to do optimize mem by not constructing new arrays here. So that'll be a to do, but I'm going to go ahead and do it for now just because it's the way that I'm thinking through doing this. So it'll be nums.slice of, by the way, left, from left index to middle index, and then from middle index to right index. To do maybe should be adjusted plus 1. Okay, I'm not sure that that right index is correct, but we'll find out it debugging. Right, this is the right array. So there's a left, and this is actually like a subarray. Left subarray, right subarray. And so what we do is recursively get it, but let's terminate if we are down to terminate recursion if length is less than 3. Okay, so if left subarray dot length is less than 3, then to do check if it includes target. I think I just do target IDX, like IDX of interest equals left subarray dot find find index. I think I can do that. Find index. I think that's right. Okay. And this would be the index of target. Left subarray dot find index target. To do add offset. And if that is not the case, then else left index equals, this doesn't seem quite right, but let me write it out anyway. Left subarray. Okay, so why am I setting the left index here? Yeah, okay, this is correct. It's kind of a wonky. It's like kind of like a different variable concern. So I might want to use a different variable. It's almost like I'm reusing a variable for a different purpose. So to do, maybe create another pointer for this. It's almost like I'm reusing a pointer for a different purpose. So it's not like really a big deal. Like programmatically it'll work, but it's like as I read it, it's kind of confusing because this left index up here is doing something very different. It's serving a different purpose compared to this left index right here. Once you get the mid, check if you found the value. Once you get the mid, check if you found the value. Leaving, but my RCM Dacian lookup solutions. Your solutions are pretty slow. All right, thanks. Later. Okay. Once you get check, yeah, that's what I did right here. Once you get the middle, check if you found the value. That's what line 16 does. All right. Ignoring TikTok, bro. So that is for left. Let's do the same thing for right. So here's the right subarray, right index. So here's the index of interest. We can just call this, yeah, right index. And I am going to create new ones for two reasons. First of all, because the original ones are constant. And second of all, because it's a different purpose. So left window, or like target index, left window target index equals -1. And then right window target index equals -1. So that would be what this is. Okay. I think that makes more sense. Thanks for the follow. Appreciate it. So find index. Cool. So at this step, I think I want to run it. I don't expect it to work, but I want to test if that find index syntax is correct. So I just basically want to run it to see if I get a syntax error. I definitely need to add the offset. So let's do offset. So here the offset would originally be 0. Here, get target from array. Nums. And I'm going to rename this cur array. Or super array. Okay, cool. So there is super array, offset target. So here the offset would be left index. There's like some kind of optimization I should be able to do here where if I check from 0 to 5, then I shouldn't have to check from 0 to 2. Okay, no, that's right, because I never actually checked 0 to 5, because I just cut it in half. Okay, so that's right, actually. All right. Cool. So this might work. I don't really think so. I think there's could be something wrong with the find index. So let's see. Process exit it with this. What does that mean? Okay, so okay, here I'm not returning the correct thing. If left window target index and right target window index are both -1, so if left window target index is -1, and if right target index is -1, then return -1. What if the left window target index is not -1? Then that means that the left window contains the target. Okay, so those would be more correct, but I still need to add the offset. Here, oh, and I also want to accumulate the offset. So offset is offset plus. Okay, so I accumulate the index offset. Yeah. I'm thinking that find index also returns -1 if it's not included. So I'm going to say if it's not -1, then return this plus offset. Otherwise, return -1. Do the same thing over here. Okay, so there is the left subarray. Let's see. Sig Sev feels like there's like an infinite loop problem, doesn't it? Let me comment this piece. Also want to make sure that I'm slicing correctly. Okay, so 456 7012. So I'm missing the 2. Yep, there's that +1 that I needed. There's 456 7012. Cool. Okay, so the only thing that I saw that was weird was the 2. So, so I got 456 in this left subarray. So it will not go in this length thing right here. Yeah, there's some, okay. It's never, the window is like never narrowing. Oh, because I passed Subarray down. That's wrong. I should pass the left array down there. So here's the left subarray, and then here is the right subarray. Okay. 4, 5, 6, and then that splits into 4 and 5, 6. Looks good to me. Find index. Find index is not a function, they say. Okay. Pretty sure it is, but maybe not in there. Maybe like not in what they're allowing. Yeah, find index is definitely a function. So, but it's not like allowed by Leetcode. All right, we can just do this the super ugly way. So it's either 0 or 1. It's either 0 or 1 because its length is under 3. Okay. Return 0 plus offset. And that will be the index. So if this is equal to the target. So if we found the target, then the index of the target will be 0 plus the offset. That's correct. Else if it's 1, then we'll do that for 1. And you might say, hey, you could just repeat this for every index. And you're correct, except that that would be an O of n time complexity, and we want the log n. And so that's why we're doing a binary search. Okay. Otherwise, return -1. So it's not that ugly, I guess. It's a little bit uglier, but it's not too bad. We need to implement this on the right hand as well. Left array dot length less than 3. Left subarray. I don't think we actually need these anymore, do we? Okay, yeah, that's fine. That's fine to leave alone. It's just for like, that's for the non-terminating case. That's fine. Yeah. Okay, so let's step through this. I think it kind of looks like what I intended. I think that's what I intended. Okay, so 4567012 splits out correctly. So left subarray, right subarray. I should be able to ignore. Should be able to ignore the whole left subarray at this point. Because it's looking for 0, right? Yeah. So is there a mathematical operation to quickly check if it's between these? To do optimize mem by not constructing new arrays here, and optimize runtime by exiting or by like returning one early if target is not in range by checking edges. So we just check like those edges of the window, and we should be able to tell if the target is like somewhere in the window. We wouldn't know the exact index, but we would know that it's in the window somewhere. And in that case, I would never do e.g. for I should never check subarray 4, 5, 6, because I know that 0 is not between 4 and 6. Specifically, I know that 0 is not greater than 4. Cool. 4, 5, 6, 7, 0, 1, 2. 4, 5, 6, 7, 0, 1, 2. And what we're looking for is a target of 0. So I should be able to find it right here. Right subarray. So right subarray 0, 1, 2. The length is not less than 3. So 0, 1, 2 should get split again. So it should go here. Let me just write here console.log right subarray. And I should see it at least twice. Yeah, see, I get right subarray only ever comes once. Yeah, okay. This is the piece that is incorrect, I guess. It's returning this one. That's what it's incorrectly returning. So I don't want it to return there. I want it to set left window target index there. Yeah, I think that's right. Okay. We should do the same thing over here. So this is a improvement, incremental improvement. 7012, 7012, and then 7012, and then 012. So this is what I expect to happen, and that's the proper termination condition. So now, the target is 0, so it should find this left subarray. Left subarray is less, dot length is less than 3. Yes, it is. So I'm expecting this to happen. 0 plus offset. Let me console.log. Left window target is 9. No, it's not 9. Log the offset here. Somehow that offset is getting increased inappropriately. So it goes from 0 to 6. How does that happen? So 6 is the far right number. Yeah, that's right. So the offset, I'm passing the wrong number. So let's see. I should be passing like the subarray offset, not the offset of the right. But even if I pass 6 here, how'd it end up with 9 here? So now the offset is 3. Zero or like 1, 2, 0, 1, 2, 3. Four. 0, 1, 2, 3, 4. left window target index. So this is like not working at all. So the left window target index is 1. So why is the output -1? Oh man, yeah, that's dumb. That needs to go in an else block. Yikes, big scary. Okay. All right, so at least I get an output of 1 in that case, which is better. So here is 1 plus offset. I'm expecting 1 plus offset should work, but I'm expecting offset has a value of 3 because the right subarray had an offset of 3. So we do 4, 5, 6, and then the right subarray here should have an offset of 3. Let's see, I'm not logging that. Let me log that. Yeah, so that offset is incorrect. Okay. So the offset is initially 0. That's correct. This 456 continues the 0. That's also correct. The 70, no, it's right. The 7012 I'm not really sure why it's divvied up into 7 and 012, but yeah, so that's incorrect. The 7012 is being divvied up incorrectly. Should be 7012. 456 7012. This offset is wrong. That's where it should have a value of 3. Right subarray offset. And that's okay because I pass middle index. Let me try that one more time. Offset has a value of 3. Okay, yeah. So the offset is 3. Why is left subarray? left plus right divided by 2. So left is 0, right is 3. That's the reason. Okay, I don't know if that really bothers me. Okay, so we end up with 0, 1, 2, and the offset is 1. So that is the issue. Middle index plus offset. Okay. Yeah, that's the issue. Okay, so the offset was not accumulating, so we fixed that. Let's submit it. So this is wrong, and 1, 3, 5, 3. They're expecting 1, and we give them 0. Yeah, so they're 100% right, of course. So again, the offset is wrong. The offset here should have a value of 1. Take this test case. So which offset is incorrect here? 1, 3, 5, left subarray is 1, right subarray. This is the offset that is incorrect. Offset, left subarray, right subarray. Offset, left subarray, right subarray. Can I just add 1 here? So I think this might be to do with the slicing. I'm going to enter this in as test case. Cool. So we run that code. Four, 5, 6, 7, 4, 5, 6, 7, 0, 1, 2. 1, 3, 5 is the case that we care about now. So here is 1, 3, 5. So it's already been split the very first time we see it. Yeah. So this is on the first loop. So here comes 1, 3, 5. This is 1, and this is 3, 5. So offset here is properly 0. Yeah, basically we're waiting too long to increment offset because we use offset within these solution blocks. So here, I basically need to compute left offset and right offset early. and use those. So that's fine. Okay, const left offset. Oh, it's like next. It's like, is it next left offset? Next left offset. It's the left offset on this one. Left subarray offset equals this. And the right subarray offset is, yeah, offset plus left index, and then this is offset plus middle index, yeah. So there is the right subarray offset. That goes here, and also onto these. Let's see now. So that was accepted in both cases, yeah. Submit. There we go, we got a winner. Faster than 5% of submissions in memory use. Right, so basically this is like not a very optimal solution. I'm gonna end it there. We have some to-dos where if I executed the to-dos, it would be faster. So like here's one. This might be fairly easy to do. Okay, maybe I'll take a crack at that one. That'll improve memory, but I don't know about performance. Okay, so, and then here's one that can improve performance, but all right, we'll see if I feel like doing that. So first of all, let me leave the console.logs while we kind of improve it. We'll get a slight speed bump when I remove the console.logs as well. Okay, so optimize mem by not constructing, and let's just record the current memory usage. Oh, it's they already have it in the test submitted. Okay, so we can see that. So that is the number that we are seeking to improve. We want that to be a big number. Less than 6%, I want it to be less than 60%. Optimize mem by not constructing new arrays here. So left subarray, we could just turn it into an array of pointers. Or, yeah, it could just be 2 pointers. Const left subarray start index equals left index. And then const left subarray end index equals middle index. So now we say if subarray subarray start index and I might not need this subarray offset thing because I could just use, yeah. Okay, might not need those. like technically I don't need them. It's like how much do I want to optimize it? You know, at a certain point you're like squeezing out memory and it's actually wrecking the code. Yeah, I like, technically I don't need them, but I like it for intuition. So left subarray.length, we can't do that anymore. So what we do is if the end index minus the start index is less than 3. So if the difference is 1, 0, if the difference is 0, 1, or 2. I actually want if the difference is less than 2. I want it if it's 0 or 1. Left subarray is not defined. Okay, where are we using that? Okay. Yeah. So we're not doing offset anymore. We're doing the array, the target, the start index, the end index. Let's go all the way down to the bottom. So really, I'm gonna copy this code because this is like a totally different implementation. Actually, it's not totally different, but it's like pretty substantial. So the intuition is like exactly the same, but there's a lot of code differences. Right subarray offset. I think this is the one that's good. Accepted, accepted. Yeah, so that's the one that's good. So I'm going to keep it and then comment. Bam, comment that out. And a lot of people like hook this up to their GitHub. Maybe I should be hooking these up to my GitHub. I suppose. So here's get target from array. Now we're doing start index, end index. So first argument is the array, second argument is the target. Start with 0 and end with nums.length minus 1. Okay. New way we're doing it. Array, target, start, end. So here the left index and the right index can just go away. For the start index and the end index. Okay. Left subarray start index. Do this for the right side. So middle left, middle, middle, end. Here, this index has already been adjusted for the off by 1 because we did length dot minus 1 in the parent. And so let's consider a situation of 3 or 4 elements. In the case of 3, we're going to floor it, so it's going to be 1 and 2, so it's going to be lopsided. So 0 to 0. And then 1 to 2. 0 to 0, and then 1 to 2. So in that case, middle will take a value of 0, but we need to plus 1 it there. Okay. And then what about in the case of 4 elements? In the case of 4 elements, 0, 1, 2, 3, 0 and 3, half, so 0 and 1, 0 and 1, and 2 and 3. So then it's balanced 0 and 1 and 2 and 3. So the middle takes an index of 1, and we, on the right hand, adjust it plus 1. So this is consistent across odd and even length arrays. Great. I think a bunch of these need to get changed. So yeah, if the left minus the right is less than 2, then we do all of this. This doesn't exist anymore. This doesn't exist anymore. Let's change these interior calls, get target from array. Now we want to do array, target, index, index, array, target, index, index. And it is the super array. It's no longer the array for that side. So the super array, target, index, index. Super array target index index. Here is the super array target index index. Okay. Right, subarray index. Yep, want to change up these rules. Okay. Okay, let's go. Convert this to right. Very cool. So I bet there are a couple things I still need to change from the refactor, but let's go ahead and run it. All right, line 165. Unexpected end of input. Maybe I didn't properly close one of the functions or something. Braces match there. Over here, this one, yeah, that's missing a brace somewhere. Okay, so I deleted an extra brace, unfortunately, somewhere. This block looks good, else block looks good, if block looks funky. Yeah, so the if block here is off. This one, yeah, this is wrong. This is wrong. How did I do that? I'm not sure how I did that. Let me try that one more time. Okay, so it looks better. So if the right end minus the right start is less than 2, okay. Cool. All right, so that was accepted. Great. Let's see if it runs over here. Damn. Wrong answer. Boo! You die. So what could be wrong here? Output of 0, expected 1. Yeah, I just have an off by 1 issue somewhere. Great. Liddy. Yeah, I think it's this one. It's definitely that one. Bam. Success. I had my offset. My offset was wrong. Oopsie. Cool. And you can look at that memory usage. So we went from, if you remember, we went from like being in the bottom 5%, 5 or 6%, to being in like the top 10%. Yo, they put a lot of chocolate sauce in my drink. I'm kind of here for it. All right, and yeah, and we could get that performance number up as well, but I think time is better spent elsewhere. Because the overall intuition of the problem, it really makes sense to me. So it would just be grinding out code, which is not useless. Like it's good to get, you know, do your Leetcodes fast so you can have more time for actual like intellectual discussion with your interviewer. But feel happy right here. The runtime also got way better too, right? The runtime went from 400 or 500 milliseconds to 100 milliseconds. I'm pretty surprised that even at 100 milliseconds, it's still, we only gained like 2%, even though it was like 4 or 5 times faster. It's kind of funny. All right, thanks for joining. I'm going to pause it there for now. I'll probably do some more later. See you later. Bye.